Hello, everybody. Welcome to this session. Thank you, Pasha, for introduction. Before we start, here is indeed a disclaimer. I work at such a great company as SonarSource that you might know by such products as SonarCube, SonarLint, SonarCloud. But whatever I'm going to present to you today, show, and whatever I'm going to tell is only my opinion. My employee can only dream that they own this opinion. They don't. It's mine. Today, I'm going to tell you a true story based on my work on Java code coverage on such a library or such a tool as Joko, as you also might know. I work on this as on many other open source projects in actually my spare time. And today, we're going to speak about Kotlin and what 1.5 brought, what interesting cases we discovered while been working on Joko. We do a lot of testing while developing Joko. In particular, we test a lot of JDK versions. We still support JDK 5, and we do test JDK 17 early access builds, which is not yet released. It's quite funny. We sometimes find bugs in JDK. Quite recently, we reported few about switch pattern matching in JDK 17. This takes our time, of course. We also test wide range of Kotlin versions. This also takes our time. And sometimes, yes, sometimes we do implement new features. About these features, we indeed gonna talk today. Like, for example, a long time ago in Joko version 0.8.1, report for code coverage report for some Kotlin classes look like this. We implemented some features, and quickly in 0.8.2 and later, we started to have such a report. Without any changes in your tests, without any changes in your source code, report started to look like this. Was original report a lie or not? We're going to see today. Why and what we implemented, we're going to see today. And we're going to see what changes we also made for Kotlin 1.5. And before we really start looking deep, it's important to understand that while Joko shows to you a report which shows your source code lines, actually source code doesn't play much role in how Joko works. Source code is shown to you at the very end, but it almost, yes, it's only shown at the end. It doesn't play a role during actual measurement of code coverage and creation of a report. Joko receives all the information from the class files. It's important, it's nice properties. Why we did so? Because then we can do online instrumentation using Java agent to record code coverage, and this, in our opinion, heavily simplifies integration. We don't need to modify your source files. We don't need to integrate into your build. You could simply attach Java agent prior to running your Java virtual machine, and we will collect code coverage information. This also has a nice property. Actually, Joko works in the absence of source files. If you have some third-party library or you have some jar, you can also measure code coverage of this jar. Yes, you're not going to see information about exact source lines, but at least you would see which methods were executed and so on. Also, this allows us to quickly cover new syntactic sugar, constructions that appear in a language without actually changing the class files, which do compile into the same constructions as many other that already existed in the language. Some example of this is switch expressions. We don't need to do anything to to support them. Text blocks, the same thing. Pattern matching, for instance, of no changes on our side, just some back reporting to JDK. Pattern matching for switch, the same thing. And also, it allows us to support languages other than Java. hello Kotlin here. This is, I would say, half true, half lie. True because yes, out of the box it was working for the Kotlin, and half a lie because we still need to tweak Jacoco to provide you a better report. Why and what we tweak we're gonna see today. So here we came to the real disclaimer. I'm really sorry. Today there will be a little bit blood. I'm going to tell you the story about Bloody Monday after the Kotlin release. And sorry, today we are going to deal with the naked Kotlin compiler. We are not going to have any IDE, just a command line and Kotlin compiler and some other command line tools. Sorry for this. We are not going to speak actually Kotlin language or, well, I'm going to speak English, but mostly we're going to speak a bytecode, another language which you usually don't touch at your daily work, I believe. And I will try to do a bit of intense of violence of your brain. So be ready for this. I hope you're ready. Pasha, are you ready?
Ready to this, but I'm trying.
Okay, let's go. Let's start from something simple. Let's start from well-known construction to every Kotlin developer, a data class. I have a data class. It's called example. It has just one property called v with the type int. That's it. It's super simple, super easy. There is no body, there is no methods, nothing, right? What we are going to do today, we are going to look at such examples. We're going to compile them using Kotlin compiler, and we are going to decompile them using a tool called JavaP, Java disassembler, or others, they call it Java decompiler, a tool which comes with GDK, which is the standard. The tool that actually doesn't decompile or disassemble, the tool that simply shows you the bytecode in a form that is human readable, more or less. So on this example, we are going to call this tool with two parameters, -v, -p. -v means verbose, and -p show me privates, show me everything, basically. This is my favorite combination of the options for this tool because it shows you everything. We're going to look on this simple example, and what we're going to see, yes, we're going to see property, we're going to see field declared in the compiled class file. What we kind of maybe not expecting to see, we didn't write any single method in this data class, but methods would appear. For example, there will be compiler generated method to string. We didn't write it, it was generated. We're going to see compiler generated method hashcode equals setter to set the field. Well, also getter and some others. What is interesting here is probably we as a users of tool like Jacoco, of code coverage tools that tries to measure what was executed, what was not, don't want to see in reports equals method. There is no need to test it. We could simply trust the compilers that the compiler generated it correctly. That's it. So in Jacoco, we need to find a way how to filter out those constructions that were generated by the compiler and that are actually not presented in the source code. In some cases, it's easy. In some cases, it's quite more tricky. All this started from the wish to really filter out method like equals and hashcode. And quite some time ago, developers from JetBrains, they actually helped us to do this. They gave us a nice hint. They knew a nice property about Kotlin compiler that we use it to implement a very first versions of such filters. This was exactly about data classes. What is interesting is that in data classes, for methods that were generated by a compiler and that should not be kind of shown to the user by Jacoco, line number table, the information in the class file that maps bytecode instructions to the lines of the source code is actually absent. As you can see on this example, we have a method component one. It doesn't has a line number table. And method setter, it indeed corresponds to the property, so it has a line number of the property. this one should be shown, hash code equals, etc. shouldn't be. They also don't have line number table. So that's how we implemented filters very first time. That's how we filtered all that to get a report like this. Pretty cool, isn't it? Yes, it is. But time goes and things change. For example, you might already know that there is a new Kotlin compiler IR backend. But what does this mean? Compiler backend is a stage in the compiler that generates executables. So if we speak about language such as Kotlin, we can generate different executables. We can generate executables for JVM. This will be the bytecode. And we can generate executables, Kotlin native, we can generate native executables. They will be binary. So this is about this part of the compiler. And IR is internal representation of a compiler of your source code. And historically, in the Kotlin compilers, there were multiple intermediate representations, and this was not convenient, nor convenient for the Kotlin compiler developers, a lot to maintain, not convenient for the users. Different bugs, different performances, etc., etc. So an effort was started to unify all this with a great promise that the new compiler will also boost the performance of compilation. This is a great outcome for you as a users of compiler. And this will also help Kotlin compiler developers to develop it faster. And there was a statement that it will become default in Kotlin 1.5. And this was announced in a blog back in February 2021. I found this reference. An interesting question here arises. Do you know when actually Kotlin 1.5 was released? Feel free to drop this in the chat if you know. Feel free to maybe Google or search if you don't know. We will check the answers later on. And yes, this is a story about how in Jacoco we went from testing early stages of new compiler backend implementation till it actually finalized in 1.5. So for us, more interesting to know is when the new IR backend really appeared, when we could have started testing it. And well, we might say that Kotlin 1.5 was not released earlier than February 2021, and probably first versions of new IR backend were around those dates, right? Something like this. Actually, if we will look at the announcement of Kotlin 1.4 back in August 2020, it already contained an experimental in alpha stage new IR backend. Pretty cool. We could start testing it, and we actually started looking at it. And actually, not just we, also you, our users. The very first ticket in Jacoco about new IR appeared in August 2020, the same time Kotlin 1.4 was released. We can go to this ticket, and we would see that, yes, seems that quite a lot of things changed in the Kotlin compiler. We quickly started investigation, and almost immediately in September, we provided some feedback to developers of a Kotlin compiler that, well, looks like it's not our problem. It's not something to change on our side. Looks like there is some problems with this new IR. And indeed, this all was considered as bugs, and they were taken to be fixed. So we stopped our efforts looking on the alpha stage there because we already knew that, well, there is some bugs to be fixed. Then time goes, Kotlin 1.4.30 goes out in February 2021. And again, it contains another interesting statement about new compiler IR. This time it goes from alpha to beta. And there is a statement like, well, you shouldn't notice any difference, but if you do, please report it to your track. And you can switch anytime back to the old backend. This also was not convenient for us to start fixing something on our side. We still were investigating whether things which we are finding can fix it or not. We also have some other jobs and personal lives. And we was quite busy in February. But time goes on, and March 2021. In March 2021, Kotlin 1.5 milestone 1 goes out. Quickly later, in the same month, milestone 2 goes out. And this was a good trigger for us. We knew that, okay, 1.5 is around the corner. It's already reaches a milestone. There probably was a lot of testing. It's a good time for us to reconsider what we have to do for Kotlin 1.5 and maybe start fixing something what has to be fixed on our side. And indeed, exactly in the March, together with those two milestones, we find cases which are justified on the Kotlin compiler side, which are expected changes to which we should adjust. So let's have a look at some of those changes. One of those changes is around default parameters, default arguments. You know that in a Kotlin, you can declare a parameter and it can have a default value. How does this compile? Let's see. Here is a default parameter. Let's do what we usually do. We're going to use Kotlin compiler version 1.430. We're going to compile this code. Then we're going to decompile it using java p -v -p. And here is what we're going to see. Here is our method, say hello. But where is our default parameter? Where is KotLand? What we can see here is just the word hello, but not the word corresponding to default parameter. This is indeed, again, artifact of a compilation of Kotlin code. Actually, hello is in another method. In another method, which is said to be synthetic, which is compiler generated. And this method indeed contains value of a default parameter. And second parameter to this method is a bitmask. Bitmask says, hey, use default values for these parameters, but not for this. And it simply delegates to the real say hello method that does all the job. And if we will have a look at our example where we call this method with default parameters, we would see at the call side, indeed, we pass a bitmask. So here we say, well, yes, use default parameter for the first one. And it invokes this method that was generated. So why there is a change on such simple construction? What changed? Let's have a look. We take the same example. We compile it now with Kotlin 1.5 milestone 1. We decompile it. Can you spot the difference? Well, it's quite hard. Let me zoom a bit. Can you spot the difference? I helped you a little bit. The difference is in this method. I also cannot spot actually the difference. It's quite tricky. It takes us a lot of time to understand why our tests fail. And we look on the bytecode. Bytecode looks like exactly the same. And here the difference is not obvious, but line number table changed. And unfortunately, the way our filter implemented, they not always take into account the fact that line number table may be here or there. They expect it to be in a certain place. So we needed to adjust this thing, and we did. Here is the changes that we did. Let's just have a look. It was simply overlooked. We just overlooked it to call one of the methods that would skip exactly this unnecessarily line number. But okay, that's fine.
I'm very sorry. I would be grateful if you could make font in your browser bigger.
Okay,
thanks.
I will do. Not on slides, just in the browser. Okay.
Yeah, absolutely.
Okay. So let's go on. Let's have a look at the other example. The other example is about late init. You know, in Kotlin, you can declare some property as late init, which basically means, well, I do not have initial value for this property, but hey, please trust me, I'm going to initialize it before the actual access to it is going to happen. So the type of this property could stay not nullable. And in this example, we have a read from late init and indeed some method to initialize this property. Into what this compiles? Let's see. We call the Kotlin compiler, again, version 1.4.30. We call the decompiler. Here is our example. It decompiles in something strange. It decompiles into not just a read, it decompiles into a null check. While you tell to the compiler, hey, man, please trust me, I'm going to initialize it, compiler cannot just trust you. Compiler should verify this fact, otherwise bad things going to happen. Otherwise, you're going to see not very meaningful maybe message somewhere. And in this case, Kotlin compiler, yes, as a safeguard, generates a null check, and this check is going to tell you, yes, well, you have initialized property. Then you can immediately go and check why your late init property wasn't initialized. And again, because this compiler generated artifacts, probably you don't want to see this in code coverage reports, and we have to filter it. So we implement a filter that finds such a null checks using exactly these 3 lines that you could see. We recognize a pattern that there is a null check. We don't filter all the null checks. We should filter one particular. So the one that can throw Kotlin specific exception, initialized property access exception. So we implemented this filter. Time goes on. We got 1.5. What changed it in 1.5? Let's see. Let's compile this with 1.5 milestone 1. Let's decompile. Let's have a look. Same example. What changed it? Can you spot the difference? Well, again,
it's much longer.
It's much longer. Well, no. The line here should be pretty much the same. The length of the line, or what is longer?
No, I mean the number of bytecodes.
Yes, the method becomes longer. Somehow this construction was added. Const null at row. Well, this could be as an exercise to you, or we can quickly have a look. I hope we have a time. This seems to be related to the following change in the Kotlin compiler. And basically, there was some bug. There was some bug in some cases which forced them to re-implement the way uninitialized properties are handled, which forced them to really call not a method to throw an exception, but really explicitly throw a null pointer. But okay, fine. We adjust to this pattern. Now we can recognize it as well. And we move on. We have more examples. Inline functions, a pretty powerful feature of a Kotlin, right? So we have such a simple example. Notice we have 2 functions, one on line 1, another on line 2. Here is inline function on line 1. Call side is on line 2. We call the first function. Into what this compiles? We again compile, we again decompile, we look at it. Well, here is inline function. Well, here is a call side. Here is a promise. Kotlin promises us to inline the function. So yes, indeed, body of a first function got inlined into the second function. There is no any more call of a function. There is just a body. And then interesting thing, if we're gonna look at line number table, we're gonna notice that there is a line number 4. We had only 2. How come is it? Well, it's also artifact of a Kotlin compiler. And this artifact, some tools do not like code coverage reporting. It would be misleadingly to tell you that, well, there is a line number 4, there is no line number 4. This artifact of a Kotlin compiler, it's actually source debug extension, GSR 45. Line numbers of inlined functions, they go far above the original source line numbers. And then using the source debug extension, they are mapped to the origin, they are mapped to the source. Source debug extension simply contains information how to map those big line numbers back to places from where they was inlined. So we have to handle this, we have to filter out those lines, and we have a parser for this weird syntax of source debug extension. And well, what happens in Kotlin 1.5.0 milestone 1? Let's see, let's compile. Can you spot the difference? Well, the difference in the source debug extension, can you spot it? Well, me neither. Actually, it was not GSR45 confirmed. There was a bug. And this bug nor was not spotted that it wasn't GSR45 confirmed, nor by Kotlin compiler developers, not even by us. We've been reading this specification. We've been reading the compiler code. We've been trying examples, etc., but we didn't spot it that it was wrong before. In 1.50, they fixed this. There is a ticket on the Kotlin compiler site where they say, well, it wasn't confirmed, let's make it confirmed. Unfortunately, it caused the fact that our parsing was not correct anymore. We were throwing an exception because we were seeing something what we don't expect. So have to fix this as well. But okay, let's move on. Time goes on, April 20, 2021. Kotlin 1.5 release candidate goes out. Time to fix really remaining problems and probably releases around the corner. So we have a few more cases to fix. We go through them. One of them is unsafe cast. So here we have nullable string and we have unsafe cast. Basically, hey, trust me, I cast this to the string which is not nullable. We compile it with pretty old version, Kotlin 1.3.0. We decompile it. What we can see, well, how it compiles. It indeed compiles into the cast, but along the cast, there is also a check whether the type is null or not. Again, compiler doesn't trust that it's okay to cast there, so it has to throw exception and again, meaningful one if it's not the case. So here is a null check. And notice how it is implemented. We duplicate the value on the stack, then we check whether it is null or not. The duplicate of value from the stack gonna go away, and the original value gonna stay on the stack. And then from the method, we are gonna just return the original value. Let's have a look how it was implemented in Kotlin compiler 1.5 release candidate. Exactly the same thing was compiled slightly differently. Can you spot the difference? Let's zoom in. Okay, let me help you. Instead of type cast exception as it was before, Kotlin compiler now throws a null pointer exception. Why they did so, you can dig on your own. It's pretty interesting story. Also, what we could notice here is instead of duplicating the value on the stack, we now load it twice. It changes the pattern. And what's funny, yes, it breaks our code because we was expecting that there is a duplication of a value on the stack. But okay, fine. We fixed this. Fine. Let's move on. Here is another interesting example that I built it for you. So in the very first case, we have exact same unsafe cast, exact same function. And in the second case, we have more or less unsafe cast, but written manually. We write manually this null check. And well, smart casts do the job for us. Once we check it that something is not null, we don't need to cast anymore unsafe or safe way, etc., etc. So let's have a look into what this compiles. If we use an old compiler, it's going to compile into such a thing. We can look on the two methods. They look different. So indeed, the safe cast uses this duplication trick, and the thing that we wrote manually doesn't use the duplication thing. It loads the values multiple times. We could also notice that, well, the way to indeed to return the value is different, not via the duplication on the stack. So let's compile the same thing with 1.5 release candidate. What we're gonna see, identical. They're absolutely identical, bit to bit. Why is this happened? Well, it was, I guess, necessarily evil why Kotlin compiler developers did it. What does this mean for us? Well, it means for us that some things like this example, Jacob cannot distinguish. There is two source codes that compile into exactly the same bytecode, and well, Jacob would believe that, well, you probably did here unsafe cast, so no need to show you this branch, and this one will be filtered out. Well, that's life. Let's have a look on the other example. You probably know such a construction as when expressions. You can do when expressions on string values. And equivalent in Java is string switch. If we compile this thing into bytecode using the old compiler, what we are going to see? We're going to see a pretty smart compiler trick, which exists both in Java, in Scala, in Groovy, in Kotlin. It is smart to do a switch by hash code, because with a high probability, we would already decrease number of cases to one or maybe few, the ones which have the same hash code. And the switches, table switches, lookup switches in JVM bytecode, they're pretty fast. It's just one jump. Then, indeed, if we have some hash code, we need still check whether it is expected string or not, because there might be two strings with the same hash code. It's exactly the case here. String A has exactly the same hash code as string BBBB. Bam. What changed? What could you change here in such simple construction, in such simple trick to quickly perform when on strings? Let's see. Let's use Kotlin compiler release candidate. Let's compile. Let's look. Can you spot the difference? Looks like the same. There is still switch. There is some equals method. There is some comparisons. It's also hard to spot for myself, actually. Indeed, it's hard. Let me zoom. Can you spot it here? I cannot, really. I was staring at this code and I was like, well, what changed? Well, apparently the ifs are different. Previously, we was checking for equality. Now we are checking for inequality. It was just inverted. But this changes the whole story. This changes the whole flow of this bytecode, and it changes the way we could detect it and filter. So again, we have to adjust to these changes. Let's see. Thankfully, we noticed that we noticed that it's almost the same bytecode that Eclipse compiler generates in Java for string switch. So we can reuse the other filter to implement it for the Kotlin 1.5. And this seems to be related to some change in the Kotlin compiler. Apparently, it related to a change where they decided to do a little bit of optimization, to not generate switch by hash code if number of cases is small. Probably it also was overlooked that at the same time, the flow equalities changes on inequalities. But well, again, that's life, not a bug, not a big deal. Let's move on. What else do we have? Sorry, pretty much nothing left. We fixed quite some issues on the way from 1.4 and alpha new IR till the 1.5 release candidate. Our testing is pretty good, shows that everything pretty much works. We still need to test maybe bigger projects, and we start wondering at which moment we should release to be ready for Kotlin 1.5 release. We also go to some friends like Pasha working at JetBrains. We start to wonder, and by feeling we get a pretty good estimate where it might happen. So again, question for you. Kotlin 1.5, when was it released? Let the var begin. And when do we need to release Jacko 087? Let the var begin. And may the force be with you. So we have a pretty good estimate. We know that it's going to happen on the week of May 1st. And it's pretty funny date, right? We decide to use this date for Jacoco release. And this gives us still about 1 week to test a big project, to test that all of this works, nothing crashes, etc., metrics are correct. So that's what we do. May 4th, Jacoco 087 release. Guess when Kotlin 1.5 gets released? Okay, we don't need to guess. We can simply go and read the release notes. We could go to kotlinland.org, there is docs about releases, and here we would see that Kotlin 1.5 was released on May 5. If you will go into GitHub repository, we're going to see the same. Kotlin 1.5 was released on May 5. All good, we released Jacoco before, everybody should be happy, it's working, we are just in time, our prediction was correct. But what happened? If we're gonna go into Maven central repository, we are gonna notice that jars, the artifacts of actual Maven plugin, Gradle plugin, Kotlin compiler, etc., they all appeared a week earlier. They all appeared in April 26, 1 week before our release and 1 week before the Kotlin 1.5 compiler official release and announcement. And it was bloody Monday for us. It was really bloody Monday for us because it was past weekend. There was Monday, there was daily work, not much spare time. And what happened? Let's see. Apparently, here is what happened. Apparently, GitHub bots started to notice that, well, Kotlin got released, which is not yet officially announced, and started to open pull requests to many projects bumping the Kotlin dependency. And of course, our release is not done, no bump for Jacoco version, etc., etc. Of course, this starts to fail just because it doesn't work. We had this exception with parsing of source debug extension, etc., etc. And people start coming to us. They see that, well, things seems to be fixed, but it's not released. Well, they start to ask question when this will be released, fixed for something which is officially not released. They still believe that issue still exists. It does not. It's fixed, but it's just not yet released. So we try to keep cool. We try to respond well. Give us a little bit of time to do the last minute testing and do the release, etc., etc. But it creates a lot of noise. It creates a lot of energy, a lot of noise from us. But okay, finally we release. Finally we do the release. Finally we announce it. People happy. People start anyway getting back to us because, well, Sims doesn't work. But it's another story. It's actually apparently there is many different ways to upgrade Jacoco. If you do Android, you need to do one machinery. If you don't do Android, you need to do another machinery. So it takes quite some time to upgrade all this tech, but Dependabot already did a little bit of harm because involved a lot of people to investigate something that doesn't need to be investigated. Something that's gonna be fixed just by a little bit of time. But all good. We went through this. It's already passed. Kotlin 1.5 released. You can enjoy performance of a new compiler. Jacoco 0.87 is released. Contains many improvements for Kotlin 1.5, even for Java, etc., etc. And here is a takeaways for you from this talk. Please understand. The further some JVM language like Kotlin goes from Java, the more exotic bytecode compiler is going to generate. And this creates a trouble for such a tools like Jacoco or bytecode analysis tools like Findbugs, Handbugs, etc. that try to analyze the bytecode, not the source code. They're going to see all of these branches that you did not write in your source code. They're going to see all this. They might see something which is not reachable just because compiler generated it on behalf of you. Please understand, yes, source code is not bytecode. What these tools are going to see in the bytecode, indeed, you couldn't see in the source code, but it is there. Please understand that bytecode-based tools like Jacoco, they only have to guess. As we've seen today, there is examples of two different source codes, but they compile into exactly the same bytecode. And we can only flip a coin to decide which source code it was initially. We cannot determine it precisely. And so please bear with us. Developers have to put up with this. We, developers of such tools, should somehow live with this, adapt to this. And you, developers of other products, of other tools, please bear with us. You have to live sometimes with understanding that, well, what is shown to you in the reports of bytecode analysis tool is exactly correct if you will have a look at the bytecode. But it might be not precisely correct if you think from the source code point of view. That's it. And thank you for your attention. Hope you enjoy it. And if you have any questions, I'm ready to take them.